Hey there, it's Andy from StuffAndyMakes.com. This is a video of the latest test drive and demonstration of the Office Chairiot Mark II over at the meltmedia offices in sunny Tempe, Arizona. Hashtag YAZ. If you don't know anything about the Office Chairiot Mark II and you'd like to find out more, go over to OfficeChairiot.com. And while you're there, go down to the bottom of the page and sign up for updates. My friend and co-worker Will strapped GoPro cameras to the Office Chairiot while I made runs around the office. I tested every sound and every light. And since meltmedia is a safe haven for Nerf gun warriors and strange goings-on, a motorized IKEA chair zipping past your desk at 10 miles an hour with sound effects and LED lighting? Not that distracting. The current firmware makes the joystick a little touchy still. It's easy to drift the chair around, especially on slick floors and carpet, and the tires are really slick. But overall, it's pretty controllable. Over the holiday break, I'm updating the throttle software to make it smoother and to provide a safe mode that limits the speed and the acceleration a bit more. The Office Chairiot Mark II is green-ish. All of the lights are LED. Every single LED light, including both headlights, all 4 turn signal lights, the brake light, and all 88 red, green, blue accent LEDs are all individually controllable. One of the features I'd been working so hard to complete before the big SEMA convention in Las Vegas was what I call Wonder Glow. It's the programmable red, green, blue LED light show under the chassis. Of course, there's also Logo Glow, the same kind of feature behind the meltmedia and Local Motors logos on the side panels of the chassis. These amazing LEDs are called NeoPixels. They're super bright, run on 5 volts, and they're individually addressable LEDs. This means you can tell each one what combination and what intensity of red, green, and blue to display. I got this bunch from Adafruit.com. These things are slick and easy to use with an Arduino. They're a little finicky about power and signal, so check out Adafruit's learning pages for best practices in using them. So the addressable LEDs and anything that requires 5 volts is powered by a 100-watt DC to DC converter. I got it off of Amazon. It takes 12 to 24 volts and drops it down to a very clean and reliable 5 volts. It's labeled as the flux capacitor under the chair. The headlights, turn signals, and brake light LEDs all use 12 volts. I got them at an auto parts store and they're switched on and off by relays. The entire 12-volt system on the chassis is switched on and off by a single automotive relay that's controlled by the accessory power switch on the control panel. So many sound effects, so little time. Let's start with the most interactive part of the Office Chairiot sound system, the IKEA chair itself. While I was at the SEMA conference with Local Motors, I met Paul Turner, president of Backer Heating Technologies. Paul's business card was a heater. That is, you press its 2 contacts against a 9-volt battery and it warms up. That's cool enough on its own, but thanks to Paul's other product line, simple and reliable resistive seat occupancy sensors, the Office Chairiot can now detect when a person is in the seat. How is this useful? Yep, the Office Chairiot Mark II is also quite possibly the world's most expensive whoopee cushion. When the alarm is not armed and the whoopee selector is switched to the on position, anytime someone sits in the chair, the Office Chairiot toots a random fart from a selection of 15 different fart sounds. But farting is just one cool feature that's made possible by occupancy detection. The other and less creative feature is the car alarm. Chair alarm. When the Chairiot's alarm is activated by the key remote, the occupancy sensor triggers the alarm whenever someone tries to sit in the chair. When the alarm is triggered, all drive systems are disabled. The sounds go nuts like a real car, and the lights go bonkers. The alarm can be disarmed with the key remote. As expected for a vehicle of such technical sophistication, the usual automotive sound suspects are there. The horn is operational and customizable, and the turn signals make a genuine clicking sound thanks to the relays that switch them on and off. Sorry, that paragraph seemed like it needed snooty high-end car feature sales guy voice.
Weapons activated.
And what motorized IKEA chair would be complete without a weapons quadrant on its control panel? Yes, this baby fires imaginary missiles at both.
Self-destruct sequence activated.
And, in case you have to walk away and leave no evidence behind, there's an advanced self-destruct system that gives you an obligatory countdown to give you time to get clear before the fireworks.
1, 0. Goodbye.
I do have to say, one of my favorite features is the onboard computer. When the control panel first boots, it pays most of its boot-up sequence tribute to Wall-E from the Disney movie of the same name. Yes, it's also a tip of the hat to Apple, since all of the firmware development and design for this beast was done on Apple computers. As you can see, as it stands today, this is most definitely a prototype vehicle. None of the electronics modules on the chassis are truly protected from anything. It would be incredibly easy to short-circuit something or blow up a circuit board because all those power wires and buses are out in the open. Believe me, I've done it. The next steps for this thing will include moving all of the things into proper enclosures. I will also be putting runs of wire inside protective sleeves. As for the control panel, its guts are a spaghetti plate of wire and boards. I'm currently redesigning most of the boards into a single motherboard, and I'm rerouting the wires in a more simplified fashion. The back of the control panel, including the support posts for the panel, are being redesigned and will be a direct replacement for the current backplate. The new one will have a stronger support structure where it mounts to the chair, and speaker holes and cable ports will be laser cut at the time the panel is built. I'm also adding a drop-open access panel to make easy access to the boards and hardware inside. Right now, I have to constantly remove and reinstall a dozen screws to gain access to the guts of the panel. I hope you enjoyed this little video update, and there'll be more to come.